Displacement is the shortest distance between 2 points, and it is quite simpler and often much shorter. It is a vector quantity, and it is a vector quantity, for example, which means it cares about the two things, the straight line, the length, magnitude, plus the direction. We have example for a pigeon. The absolute master of a displacement is a home pigeon. You can confuse it and drive it in a circle inside a dark box and release it hundreds of miles away in a place it has never seen. It does not retrace your drive. It calculates the simple direct vector home. Another, we have an example of a great circle route aviation. When you look at the flat map, the flight path between New York and London look like a long curve. Airlines, however, does not fly in a curve unless they must fly as the crow flies across the surface of the globe. The shortest path, this is the shortest path way between the 2 points on surface on the fair is called the great circle route. If the airlines flies from New York to London, then the air immediately flies back to New York. This is the best example for the displacement and the distance. Here we have another example of displacement and distance. There is a man who is covering a total area is known as called the distance, and there is an other man who is traveling from point A to B from starting to the ending point, and its total cover the 5 kilometer. So which means that this man is covered a displacement, and the first one is covered the distance, which is the total area. Now we will talk about this picture. Okay, we have a distance and the displacement, the cosmic distance, the astronomical unit. The distance changes the perspective completely in a space. We transition from the miles and the kilometers, the fundamental yardsticks of a solar system. The astronomical unit is AU. This image shows how the astronomers defines AU, 1 AU, the average distance from the Earth's center of the Earth to the center of the Sun. When we discussed the vast distance to the other planets like a Jupiter or a Mars, we measure them relative to the established, standardized, and rather than trying to use that astronomical numbers like that, they are too small for this. So it also explains the distance and the displacement as well. Thank you.